Okay, so our objectives for today are going to be to use geometric mean to find segment lengths in triangles. Okay, so geometric mean is a little bit different than arithmetic mean that we're used to, where we just find the average by adding up a whole bunch of numbers, then dividing by the number of values. So this one's going to be a little bit different concept. And we are also going to apply similarity relationships in right triangles to solve problems. And obviously our vocabulary that we're going to discuss here is geometric mean. Okay, so we'll take a look at our first theorem here. Okay, this one says that in a right triangle, an altitude drawn from the vertex of the right angle to the hypotenuse forms two right triangles. Okay, now remember, we have to remember this word altitude. Okay, so this word altitude is going to be a segment from a vertex to the opposite side of a triangle that forms two 90-degree angles. Okay? And so that's exactly what we actually have in this particular picture here. Okay, and so if we look at our picture here, before we even read this, we see this bigger triangle. Okay, we see this right angle right here. Okay, and this blue line is taking basically the perpendicular path to the opposite side of the triangle. Okay, and we can see that there are going to be two right angles actually formed here. Okay, and so we have again three right angles total. And so we have to understand that all of these particular triangles are actually going to be similar, okay? Meaning that they're going to have the same angles, or their corresponding angles are going to be congruent, and that their corresponding sides are going to be proportional. Okay, so one skill that we're going to practice here is actually maybe redrawing these triangles separately. So I'm going to draw maybe one big triangle like this. It's supposed to be a right triangle. Okay, I know the picture's not going to be perfect. I'll draw kind of one medium-sized one, and then I'm going to draw one small one. Okay, and we have to be comfortable trying to figure out where these vertices are actually going to land. So I'm going to just draw all the right angles right here, and let's just pick those out first. Okay, so if we look at the biggest triangle that we can see here, our vertex of the right angle is going to be C. So I'm going to label this one C. If we look at maybe the medium-sized triangle here, I'm going to try to outline it in maybe green. So this is like the medium-sized triangle here, okay? And we can see that D is actually going to be our vertex there, okay? So our medium-sized triangle, D is going to be where that 90-degree angle is, and our smallest triangle is actually going to be D as well, okay? And I can maybe outline that triangle in like blue here, okay? And that would maybe be our three triangles, okay? And now let's go ahead and take a look at maybe what the shortest side would be. So from our vertex, which is going to be our right angle, and maybe look at the shortest distance, okay? So we can see that from C to B looks like the shortest distance. It looks like it's shorter than CA, so I'm going to call this B. Okay? And that must mean the other one's going to be A. Well, that's pretty obvious because it looks like the exact picture, right? Now let's look at a couple of the other ones. So maybe the medium-sized triangle. The shorter distance from either DA or DC. DC looks a little bit shorter, so I'm going to call this C, and that must make the other one A. Okay, and then finally, on this last little triangle, it looks like the shortest distance from D is going to be B, so I'm going to put B right here, and that must make my last one C. Now let's maybe look back and see if we're actually correct. Okay, so we have triangle ABC to start. Okay, so we went basically A to B to C, and then we now have ACD. So we have ACD right here. So A to C to D, so we know that we're correct. And finally, it's going to be CBD. So C to B to D. Okay, I hope that was helpful. We're going to look at a couple problems that are very, very much like this. That kind of helps us draw the triangles separately and to sort of understand this particular theorem that involves right triangles and their altitudes.